Okay, if you're wondering what the music's for, it's Nintendo, and that's because that's literally the only thing that comes up on my recommendeds now because of the amount of times I've used it. Mic check. Okay. Now, we're not going to learn anything new. We're just going to go over some problems associated with the normal distribution. So let's suppose that I've got the heights of a large group of adults. Notice it said large, so kind of like a larger sample size. Oh, also my thing's in the top corner still. That's still going. Also, there hasn't been a 6 yet. That means nothing was going right all of the time. So if there's a half chance in the 6 of them, that's half to the power of 6, which is 1 on 2 to the power. It's a big probability. Anyway, getting distracted. It's a large group, large sample size. They've told me its normal distribution. They've told me the mean, and they've told me the standard deviation. They want to know the percentage of heights that lie between these two scores. Now, it's 100% going to be the case that these two scores are a certain amount of standard deviations away from the mean. So 170 is actually 8 away from 178. So that means that this score is a standard deviation that way. But I'm more of a visual learner. I don't want to have to just think about that in my head. I like to actually draw a picture. So that's what I'm going to do. So I'm going to draw this distribution. And honestly, this may sound stupid, but I do this for every question. So I just quickly go, okay, well, there's a line, that's terrible. Let's do this nice. I don't like that drawing. Oh, it kind of tails off, okay? Oh no, kind of tails off, so I'll kind of like that. Okay, so then I chuck the mean in. So the mean is, what did it say? 170, 170. And then 1, 2, 3, 1, 2, 3. Just draw 3 standard deviations each way, because that's all I know, right? That's the empirical rule. Let me. I'm just going to try and get the rule up. So I'm going to remember what it is. Can you see that now? Yeah. Okay, so I like to kind of model that, just like redraw that essentially. Okay, so then this is 1. Now, because the standard deviation is 8, that means I'm going to start adding 8s. So plus 8, plus 8, plus 8, minus 8, minus 8, minus 8. So then this is 178. This is 186. And this is 194. Why was that so hard? 162, 154, 1 something 6, 146. I don't know why that was so hard. It's making me look stupid. Anyway, what do I want? The percentage of heights between that. Okay, so that means that this percentage in here, okay, this is 68%. Let's do it like this. Let's go there. That's 68%. So just looking at that picture up there. Oh, I keep pointing over there. That's 68%. So that means that I have what percentage of scores? Well, 68% of them do. Lie between this and this. They're both one standard deviation away. So 68% is this. Okay. What percentage of heights are more than 178 centimeters? So that's asking what is this? So what percentage is that? And it's really easy when you have this picture, but it can be kind of hard to work it out sometimes. But if you've got this picture, it helps. So normally at the start of an exam, knowing that you're going to have normal distribution questions in here, you probably just quickly draw this. Anyway, so just straight up adding them. I know that 1 standard deviation away to the rest, so it's going to be 13.5 plus that plus that. So it's going to be 13.5% plus 2.35% plus 0.15%. And that's equal to, damn it, that's, what have we got here? That's 0.5, that's going to be 2.5, 13.5 plus 2.5 is 16%. That makes sense. But if you didn't want to work it out like that, like if you didn't have that, if you only had the 3 values like 68, 95, and 99.7, what you would do is say, okay, well, if that's 68%, then this and this is going to be what's left. So 100 minus 68 is, why am I so stupid today? It's 32. So all that's left is going to be 32. That means this has to be 16 and this has to be 16. So that would have made way more sense to do it like that. Okay, so that's that. Now, B. Go with I. All right, if a random sample of 6,000 adults, if a random sample contains 6,000 adults, how many have a height of this? So first, you're still going to work out the percent. So I want to know what percentage of them, and it's going to be, my final solution is going to be what percentage of 6,000 adults. So 146 and 194. So 146, that's 1, 2, 3 standard deviations away. And the 194 is also 3 standard deviations away. So that's all of this, which, looking at my thing, is 99.7%. So that's 99.7%. And I want to know how many people. So that means of 66,000. So literally in my calculator, I'm going to go 99.7% times 6,000. And that's going to be 5982. So that kind of means that, 18 people are going to be outside of 3 standard deviations, which is not that many people, which is what you'd expect, which is kind of like with this, there's not that many that are going from with 0s and 6s. There's only been 12 out of 412, 11 out of 480, 190. I think I need to start. My maths getting terrible. Okay, aye, Captain. Between 162 and 186, so 162 and 186. So these are the ones that are a little bit weird. So if I get rid of this, I'm looking for this plus this, okay? So this here is going to be 34%, or it's half of 68%. So however you want to work that out. And then this is going to be 34 plus 13.5. So 34 plus 13.5%. Okay, so 34% plus 34% plus 13.5%, and that's going to be 68 plus 13.5, 81.5%. And so that's how you solve problems with the normal distribution. You just draw a normal distribution, figure out how many things are, or what values are the 3 standard deviations. And once you have that, and you have this picture of the percentages, it shouldn't be that hard. So if you want, stop at that example, because all the examples are going to kind of be like that. So if you want to stop the video there, you can. But what I'm going to do is, I'm going to do questions 4 and 6, which are multiple choice. And I'm going to get you to do 5, 7, and 3, I think. I can't remember what I put in there. Anyway, let me move that because that's close down there. Okay, so stop if you like, but I'm just going to go over 2 of the the textbook questions, because sometimes I find the textbook questions are different to, or this is what I get told, different to the ones in the examples that I give. So that was a little feedback that I got from the question that I posted. So remember when I posted this thingo, enjoy your holidays, and I asked for some feedback. This is one of the ones I got. That sometimes the questions aren't the same, so I thought I'd do 2 of them. Okay. A factory makes circular brake discs with a mean diameter. So they give you all this context, they give you a full paragraph. All you care about is that you're looking for 3 things. You're looking for the fact that it's normally distributed, you're looking for a mean, and a standard deviation. Okay, that's the 3 things you want, and then you draw a picture from there. So I draw my picture. That's my, and then I put the mean, and then 1, 2, 3, 1, 2, 3. So the mean is 300. The standard deviation is 2. So that's going to be 302, 304, 306, 298, 296, 294. So then that's plus 2, plus 2, plus 2, plus 2. I hope that makes sense. Okay. So just by looking at that, 68% of the scores are going to be in here, so between 298 and 302. Okay, if diameters are more than 3 standard deviations from the mean, they're rejected. So this is a real thing. So a factory makes a bunch of circular brake discs, and obviously there's going to be some form of error, like they're all not going to come out exactly perfect, but what they're going to do is if they're so far away from the average, so far being 6 away from the middle, or 6 away from the middle, then they say, no, that's not good enough to sell, so they just chuck it. So that's actually what happens in, you know, when you buy, you might not know, but when you buy eggs, there's like different sizes. So there's like a medium, large, and extra large. For them to be considered extra large, they have an average, and then what they do is they have a certain amount of standard deviations away from that average. If it's too low to be considered extra large, it's then considered large. So that's stuff that actually happens in real life. They use normal distributions because obviously they've made so many eggs that they have the data to support what warrants one being extra large, and they can go from there. So that I'm just huge tangent or whatever. So if it's 3 standard deviations away, it'll be rejected. So remember, just from up here, that's going to be 0.3% of all the ones that they make. So that's going to be tiny. So this little 0.15% of them are going to be too small, and 0.15% of them here are going to be too big. So most of them are going to be like between 298 and 302. Anyway, what is the question even asking? If the diameters are more than 3, they're rejected. Which of the diameters would be rejected? Okay, so in other words, it can't be lower than 294. So these are my two conditions. Can't be less than 294, and also can't be greater than 306. That would be too big. So this one's fine because it's sitting in here. This 307, that's not good because that's over here, that's further than 3 standard deviations. That is exactly 3 standard deviations, so that just cuts it. And this one cuts it because that's exactly 2 standard deviations away. Okay, so then it would be this one. All right, last one. The nicotine content of a brand of cigarette. Yeah, great question. Brand of cigarette is normally distributed. Oh, great. So these are the things I'm looking for. Normal distribution, mean of that, standard deviation of that. What percentage is between those two? So the easiest way to do these, again, just draw the picture. So I'll draw the picture. Mean, 1, 2, 3. Okay, that's pretty bad. 1, 2, 3. 1, 2, 3. What's the standard deviation? 1.2. Okay, so the mean's 4.5. I'm gonna go 1.2, 1.2, 1.2. Okay, I'm looking for 13.3. Where's that going to be? Well, this next one's going to be, let's just fill them in, eh? This will be 15.6, 16.7. Have I stuffed that up? Yeah, I have. 15.7, 16.9, and then 18. This one will be pretty good at addition, 13.3. And then 12.1, that'll be 0.9, 10.9. Okay, move that. All right, so the key ones are 13.3 and 15.7. So 13.3 is there, 15.7 is there. So that means I'm looking at this, and I know that that is 68%. So what percentage are between those two? Well, 68%. Okay, so it's not too hard. It's just draw the picture, identify that it's normally distributed, whichever question is going to tell you, identify the mean, put it in, and then start working standard deviations away, and then just figure out what the question's asking. The hardest part is doing ones like these ones, is doing ones where they're kind of split up. But if you've got this picture, this one where it actually has the percentages of each little section, then you should really be fine. And let's check on our, whatever that's called. Looking pretty normally distributed to me. Not bad.